You may have seen this viral footage, two seas meeting, their waters sharply divided as if by an invisible wall, but what's really happening here? These dramatic boundaries, where two bodies of water remain distinct in color and texture, have fascinated people for centuries. The secret lies in the science of oceanography. When two water masses meet, like the Baltic and North Seas or the Amazon River flowing into the Atlantic Ocean, their differences in salinity, temperature, and density prevent them from mixing quickly. The saltier, denser water resists blending with the fresher, lighter water, creating a visible line called a halocline or in some cases a synchnocline. These boundaries can shift with the tides and change with the seasons, making each encounter unique. Scientists use advanced instruments like satellites, underwater sensors, and water sampling devices to study these ever-changing boundaries. By analyzing data, they can track how these lines move and evolve, revealing the dynamic nature of our oceans. The phenomenon is called a halocline, or sometimes a synchnocline, a boundary formed by differences in salinity and density between two water masses. It may look like a glitch in nature, but it's a perfect demonstration of physics and chemistry at work in the ocean. For centuries, sailors and explorers marveled at these sharp boundaries. Ancient maps sometimes marked them as mysterious or forbidden. Today we know these lines are created by differences in salinity, temperature, and density, physical properties that prevent rapid mixing. When two water masses meet, one saltier, one fresher, or with different temperatures, their densities differ. The denser water tends to sink, while the lighter water stays above, creating a visible interface that can stretch for miles. In the Gulf of Alaska, for example, glacial meltwater, fresh, cold, and less salty, meets the warmer, saltier Pacific Ocean. The result is a swirling halocline visible even from space, where the two water types resist mixing. Another striking example is the Strait of Gibraltar, where the Atlantic Ocean and Mediterranean Sea collide. Here the difference in salt content and temperature forms a sharp, visible divide known as a thermocline. Scientists study these boundaries using satellites, underwater sensors, and water sampling devices. Satellite images reveal the sharp lines, while close-up research uncovers how microscopic mixing occurs at the interface. The halocline, thermocline, and synchnocline are all types of stratification layers. A halocline is driven by salinity, a thermocline by temperature, and a synchnocline by overall density. These layers act as barriers, slowing down the mixing process between water masses. Over time, ocean currents, wind, and tides gradually blend the two seas together, but the process is slow and complex, influenced by the physical and chemical properties of the water. These boundaries are not just visual wonders, they have real ecological impact. The unique conditions at the interface support diverse marine life, from plankton blooms to fish nurseries, and influence nutrient distribution across the ocean. Some species thrive in these transition zones, taking advantage of the unique mix of nutrients and temperatures. Scientists continue to study how these boundaries affect biodiversity and the health of our oceans. So, while these boundaries may look miraculous, they are a beautiful demonstration of the laws of physics, chemistry, and biology at work. The next time you see footage of seas that never mix, you'll know the real science behind the spectacle. The sight is mesmerizing, a sharp, visible line where two seas meet, their colors and textures refusing to blend. But what causes this phenomenon? It's all about the interplay of salinity, temperature, and density. For example, in the Gulf of Alaska, glacial meltwater is less salty and colder than the Pacific Ocean, so the waters resist mixing. The result is a persistent halocline, visible both at the surface and in scientific measurements. At the Strait of Gibraltar, the Atlantic and Mediterranean meet, but their waters differ in salt content and temperature, creating a visible boundary. Ocean currents in the shape of the seafloor help maintain this divide. Scientists use satellites, underwater sensors, and water samples to study these boundaries. Satellite images reveal the sharp lines from space, while close-up research shows how microscopic mixing happens at the boundary. These boundaries are not permanent walls. Over time, mixing does occur, but the process is slow because of the differences in water properties. The boundaries can also impact marine life, creating unique habitats for certain species. Many people think these seas never mix at all, but that's a misconception. The mixing is just much slower and less visible than we might expect, governed by the laws of fluid dynamics. So, while the sight may look like a miracle, it's actually a fascinating example of physics, chemistry, and biology at work in our oceans. The next time you see seas that never mix, remember, it's not magic, it's science in action. In summary, the phenomenon of seas that never mix is a result of differences in salinity, temperature, and density between water masses. These boundaries, known as haloclines, thermoclines, or pycnoclines, are natural interfaces that slow down mixing. Scientific research using satellites, sensors, and water samples has revealed that, while these boundaries appear sharp, gradual mixing does occur over time. These zones also support unique ecosystems and play a crucial role in ocean health and biodiversity. Understanding these processes helps us appreciate the complexity and beauty of our planet's oceans. You've probably seen those viral videos, the ones where two seas meet, their waters sharply divided as if by an invisible barrier. On one side, the water is a deep blue, on the other, a cloudy turquoise. It almost looks like a special effect, but it's completely real. Let's break down what's really happening. When we see these dramatic splits like in the Gulf of Alaska or the Strait of Gibraltar, it's the result of ocean stratification. This means the water masses have different properties: salinity, temperature, density, and even turbidity, or how clear the water is. Salty water is denser than fresh water, and cold water is denser than warm water. When two masses meet, the differences in these properties create a temporary boundary line called a halocline or thermocline. The denser water sinks, the lighter water floats, and the two resist mixing right away. But here's the catch: this separation is only temporary. Over time, wind, waves, tides, and ocean currents slowly blend the waters together. The sharp lines we see in viral clips last for hours or days, not forever. So while the illusion of seas that never mix is striking, it's simply nature's way of revealing the invisible forces that shape our oceans. Next time you see those split-screen visuals or stunning drone shots, remember, it's not magic, it's science, playing out on a global stage. Now let's dive deeper and see what's really happening beneath the surface. Imagine two animated streams of water, one dark blue representing salty, dense water, and one lighter blue showing fresher, less dense water. As they meet, a clear boundary forms, a visible line called a halocline or thermocline. This is where the magic of ocean science takes center stage. Salinity, the amount of salt dissolved in water, plays a crucial role. Higher salinity means higher density, causing that water to sink below fresher, lighter water. Temperature matters too. Cold water is denser than warm water, so it naturally sinks, while warmer water floats on top. These differences create distinct layers in the ocean, almost like a layered cake. Animated arrows show how, at these boundaries, mixing is slow. The layers resist blending, and that's why we see those dramatic lines from above. But over time, wind, waves, and currents stir things up, gradually erasing the boundary as the waters mix. So next time you see that sharp divide between ocean waters, remember, it's not an unbreakable wall, but a temporary boundary shaped by the fascinating science of salinity, temperature, and density. The ocean is constantly moving, layering, and blending, revealing the unseen forces that govern our blue planet. Now let's journey around the globe to see these ocean boundaries in action. First, we zoom in on the Gulf of Alaska, where dramatic drone footage shows a cloudy, light blue river of glacial meltwater meeting the deep blue Pacific. Here, the stark contrast is due to the difference in sediment and salinity. The fresh, silt-laden water resists mixing with the salty ocean, creating that famous swirling line. Next, we move to the Strait of Gibraltar, the gateway between the Atlantic Ocean and the Mediterranean Sea. Underwater animations reveal how the saltier, denser Mediterranean water sinks beneath the lighter Atlantic, forming a layered flow that scientists call water exchange. This ongoing dance shapes the ecosystems on both sides. Traveling south, we arrive at Cape Agulhas, the southern tip of Africa, where the warm Agulhas current from the Indian Ocean collides with the cold Benguela current from the Atlantic. Satellite images highlight the swirling eddies and sharp color changes, a result of temperature and salinity differences, as well as powerful ocean currents. Finally, we visit the meeting point of the Baltic and North Seas near Denmark. Here, footage shows a visible line where the less salty Baltic water meets the saltier North Sea. This boundary, called a halocline, is so distinct that sailors have noted it for centuries. At each of these locations, the mesmerizing lines and swirls are not permanent barriers, but ever-shifting boundaries shaped by the interplay of temperature, salinity, and ocean movement. These real-world examples remind us that the ocean's secrets are hidden in plain sight, waiting to be explored. Now let's tackle the big question: do these seas really never mix? Viral videos might make it look like there's an invisible wall between oceans, but the truth is far more fascinating. Watch as we overlay time-lapse clips and animations. Those dramatic lines and color changes are just the surface story. Think of it like pouring oil into water. At first, the two liquids form separate layers, but with a little time and movement, they eventually blend. The ocean works in a similar way. The boundaries you see, called haloclines and thermoclines, aren't fixed walls. Instead, they're temporary differences caused by salinity, temperature, and density. Over weeks, months, or even years, these waters slowly blend together. Powerful currents, wind, and tides act like giant spoons, stirring the ocean and gradually erasing those striking lines. Scientists use dyes and tracking devices to follow this mixing, and their research shows that while the process is slow, the seas are constantly exchanging water, nutrients, and even marine life. So, next time you see a viral clip claiming that oceans never mix, remember, the real story is about patience, motion, and the hidden forces shaping our blue planet. Now that we know the seas do mix, let's explore why those temporary boundaries, known as ocean stratification, matter so much. Picture vibrant coral reefs, swirling schools of fish, and vast marine forests. These breathtaking ecosystems thrive thanks to the delicate layering of the ocean. Stratification helps create unique habitats, allowing a rich diversity of life to flourish in different ocean zones. But the impact goes even deeper. These layers influence how nutrients like plankton and minerals travel through the water. This cycling supports the entire food chain, from tiny shrimp to massive whales. Stratification also plays a key role in regulating the Earth's climate. It affects how heat, carbon, and gases move between the ocean and the atmosphere, helping to shape weather patterns and even the stability of our climate. Climate models show that changes in stratification, caused by warming seas or melting ice, can disrupt these vital processes. This can affect everything from the health of coral reefs to the frequency of storms and the balance of life in the ocean. So, those seemingly simple boundaries between ocean layers are actually crucial for maintaining the balance of life on Earth. The next time you marvel at the ocean's surface, remember, beneath those waves, an invisible architecture is quietly supporting our planet's health and future. In the digital age, the story of seas that never mix has taken on a life of its own. Social media feeds are filled with dramatic photos and viral videos, often claiming that these ocean boundaries are proof of supernatural events or ancient prophecies. Some posts pair stunning visuals with religious or cultural interpretations, suggesting that science has finally caught up with spiritual wisdom. But while these narratives can be inspiring, it's important to separate faith from scientific fact. Science helps us understand the physical processes behind these mesmerizing phenomena, like differences in salinity and temperature that create visible boundaries. Meanwhile, faith and culture offer their own rich perspectives on the wonders of nature and our place within it. Instead of seeing science and belief as opposites, we can appreciate how both enrich our understanding of the world. The ocean's mysteries are vast, and there's room for awe, curiosity, and respect for different viewpoints. So, the next time you scroll past a viral post about unmixing seas, remember, appreciating the beauty and meaning of our oceans is about embracing both the facts and the deeper stories we share as humans. As we zoom out and see our planet from space, the vast glowing oceans become a breathtaking reminder of Earth's uniqueness. Beneath those shimmering surfaces, an entire world thrives, teeming with life, color, and endless mysteries yet to be discovered. The boundaries and illusions we've explored today are just a small part of the ocean's incredible story. Every wave, every current, every hidden layer tells us that the natural world is more intricate and awe-inspiring than any viral myth could capture. Scientific curiosity is our key to unlocking these secrets. It drives us to ask questions, to seek evidence, and to marvel at the answers we find. But wonder itself, our sense of awe and excitement is just as important. Together they spark a deeper appreciation for our blue planet and a desire to protect it for generations to come. So let's keep exploring, keep questioning, and keep celebrating the ocean's wonders, because the more we learn, the more magical our world truly becomes. Thanks for diving into the wonders of our oceans with us. If you enjoyed unraveling the mysteries of the seas that never mix, don't forget to hit that like button and subscribe for more mind-blowing science stories. Got questions or your own ocean myths? Drop them in the comments. We love hearing from curious minds like yours. Check out our previous videos here for even more fascinating facts about our amazing planet. Remember, the ocean is full of surprises, and so is learning. Stay curious, keep exploring, and we'll see you in the next adventure.